Hello, here is a tutorial on the analysis of a network and the choice of pumps. According to the network load curve and the pump load curve. The load curve is the evolution of the pressure necessary for operation as a function of the flow passing through the network. How to edit a load curve, i.e. a curve of evolution of the pressure drop and of the load necessary for operation according to a flow rate range. This is not complicated. We will select, for example, in this network there. Create a generator realizing the flow of 10 cubic meters hour. By using this function, the software is forced to create a theoretical generator which will provide enough pressure to generate the equivalent of the pressure drop of the network at the desired flow rate. To view this pressure drop curve as a function of the flow, we have a tool, the network load curve comparator. To insert a load curve, you must first save the network in question. So here we did a flow test at 10 cubic meters. Now just save this network. We are going to give a significant name, so, single loop network. At 10 cubic meters hour. We record. And we use the curve comparator tool. Then the curve comparator tool allows us to access the pressure drop curves of the different networks that we have recorded. On one side here we find the pumps, which have been saved in the pump library. And here we have the possibility of inserting a network curve. Here we are going to insert the load curve of a saved network. We are going to use the one we saved. And so we see the load curve of the network evolving according to the flow. We had selected a network for 10 cubic meters. So the range is centered on the 10 cubic meters hour that had been defined in the network. We can therefore compare this network load curve with pump load curves to see if they are appropriate. So here we are going to select a pump and do a drag and drop in the interface to display its curve next to the network curve. So here we see the pump curve and here the network curve. It is quite clear that this pump is not at all suitable. For this network, it would be oversized, because it provides a pressure much higher than what is necessary to operate this network. We also have the possibility of inserting pressure drop curves for this network, but with other settings, for example. Let's see. Let's go back to our network, which has a valve, and we're going to select the valve and modify it and close it some more. We recenter on the valve drawing. Voila, I select the valve. This activates the valve modification button. It is a ball valve, closed at 10 degrees. We select this ball valve, and we are going to close it at 50 degrees. We are going to update the pressure drop calculation to 10 cubic meters hour. So we create the generator at 10 cubic meters hour to recreate the head loss curve at 10 cubic meters per hour. Here, and we save as. To differentiate it from the previous curve, we save with the mention 50 degrees to differentiate it from the other. We return to our comparison tool, and so we go and look for this curve that we have just created. And we see it displayed in yellow. We see that the more closed valve generates a much greater pressure drop, and that its evolution is much steeper. We could therefore enter different pump curves to compare them to our pressure drop curve, and thus quickly select the most appropriate pump. We see the efficiency curves appear, and the NPSH curves, and we will be careful to choose a pump whose efficiency curve is optimum at the desired flow rate. Here is a quick presentation of this tool, analysis of pump generators and network curves.